So let's zip through design considerations, process, and drivers. There is a design process, and I'll just walk through each step. So at the very beginning, you want to define the power consumption and electrical characteristics of the spacecraft bus and components. Here's an initial budget for the way that you should distribute power in your spacecraft bus. The payload is what should really drive. So the payload should typically take between 40% to 80% of your spacecraft. Your attitude control, if you have actuators that take up a lot of power, 15%, comms, 5%, command and data handling, 5%, and on and on. Power takes up quite a bit, and structures, pretty much nothing. You can size your overall power system by saying that if you want to target 40% for your payload, and you know your payload takes up, say, 40 watts, then your overall power system needs to be rated for 100 total watts. Yep, so that was just the step that I went through. Yeah, so that's a good initial distribution. Next, you select your power generation and energy storage methods, and then you analyze the system's power budget and profile from the beginning of the mission to the end of the mission to ensure the selected components are sufficient to supply power. This is a snapshot of Artemis CubeSat kit's power budget and profile. So you can see here that we looked at an orbit. We looked at the amount of power generated from our solar panels. We also looked at the amount of power consumed per mode over the time that it takes to go through that mode. And you just want to make sure that the amount of power generated and the amount of power consumed over some period of time, in this case in orbit, balances out, that you can recharge to the level you were at the beginning of that cycle. Yeah, so once you are confident that the components, your system architecture, can balance power, then you can start to think about the nitty-gritty details of designing a power conversion and management system that handles all of the interfacing between the power sources and power consumers. Here is a PCB board, a design of this is the payload board. So you can see there are a lot of different components that handle that interface. Yeah, and then I'll ask Amber Amaihong, an avionics engineer in our lab, to walk through how to make these kind of schematic diagrams. But this is later on in the process. This time around, we'll just be worried about up to this step, the power budget step. All right, later on in the process, we procure, buy, and fabricate components. Here are batteries. Here is an EPS board, electrical power system board. Here are some students who are working on the integration and assembly of the various boards. And you can see these little wires coming off that connect to the boards. Then we conduct tests. Here are the batteries in a thermal vacuum chamber inside a hazard-safe bag. And to review, here is the procedure of how to design, fabricate, integrate the electrical power system.